got our plan. We've got our plan for today. We've currently got our click tracking AI, and you can see here that it sort of averages out in the middle where all the clicks have happened. Just kind of, well, eventually it gets there. You can see it trying to learn right now. See, it'll get there. It gets there. Hey, I'm gonna be updating our. Hey, Neva, we're taking your idea. So remember on last week on Friday, where we had the click tracker, we're gonna implement the CNN, the convolutional neural network. We're gonna see if that does the trick. I think it will. And so that's the plan for today. We're going to be taking our click tracker. That's going to see if we can figure it out. I think it can. Just so we know what we're building. I think we should be able to see it all on the screen. So actually, that's a good idea. Because we need to define how many filters there are. I understand the filters. I understand the filters that are capturing the data in the window. Now, we don't have a lot of input data. So that's one of the challenges, right? We don't have a ton of input data. So I'm interested in making sure that we can capture as much meaning and intent within it, or if we need to collect a lot more clicks, right, as the input window, which might be something that we need to do. Beating on a specific task. Let's just double check. Let's go back over here. So check this out. So we've got this. These are all the green dots on the screen are me clicking on with my mouse. So me clicking with the mouse. And I've recorded all those. And that is the input data for an AI model that we created previous streams. And the yellow dot is the output where it's trying to predict where the user is going to click next. As you can see, the yellow dot doesn't totally do a perfect job. It's not fully doing a great job. So we need to modify the model to make it good. We want to make it good. We'll Googling it because I'm not on Discord. All right, we'll Google it here in a second. We'll definitely Google it. So I was just describing to just a random this one thing really quick. So here's the CNN that I'm looking at really quick. So we'll do something simple and small and tiny. And so we'll be adding this. Actually, we'll probably creating a new model, and then using that as because our current model looks like this. Let's see, model. Where is that at? Where is it? No. MOD, I know it's there. Here, right. So here's our current model. Basic, simple model. Neva, right here, said to use CNN, maybe all LSTM as well, for time series. We'll see how that works. So I have a whole lot of data. Unless we want to sort of collect a whole bunch of data up front, right? So we need to collect a whole bunch of clicks, like mini clicks, like a lot of clicks. If we get enough clicks, then we'll have enough data. Let's at least get let's at least get this going here. So we're gonna do sequential torch.nn .cnn. What was that? We're gonna do this. Let's see. Oh, we'll just do this here. Okay. Torch nn conv2d. Okay. Did I do? I'm just checking to see here. Where's that at? Where's Torch at? Torch. Oh, it's right here. Oh, I already have NN opened. Okay, I already have NN available. Let me pull this up here at the top so I can get everything in the same spot. All right, excellent. You don't have a lot of weights in a CNN. It's just like 9 weights per layer. Is it really? That's not a lot. That's not a lot at all. Like you can keep it under 40 weights if you want and keep small data use right here. Okay, let's do this. We'll get rid of that because we don't need that. We'll just do NN. Let's use NN. NN.conv2d, right? 2D. And then our inputs, we'll kind of copy. I don't know what we actually need here. So there. Okay, sounds good to me. All right. And then we're going to have a max pool of 2x2. NN.max pool 2D. 2D. We'll start with 2D, and then we'll see if we can get up to 3D. 2. And then another conv. This time, though, it's bigger on the inputs. 6, because I don't know why yet. We'll figure it out. 16 and 5. Okay. Yeah, for having one channel, adding channels is giving you a multiplier for what the linear layer weights would be. So, oh, got it. So, I mean, because essentially each, this is saying how many RGB value, like is how many color channels there are, is my understanding, right? So if it's grayscale, it's going to be 1. If it's, red, green, blue, it'd be 3 as the input. And if it's red, green, blue, alpha, we'll have 4. And then if you have like maybe, I don't know, radio frequency or it's gamma rays, right? You can put it up to 6. Like you could have a whole bunch of inputs. So I think just 1 for now. We'll just try 1. We'll see what happens. We'll see what happens with just 1. I think we'll find out. Okay. And then it wants, then we go into linear. Okay. So very simple up here at this, and then we'll go into linear. And what was the linear input? So why is it the input on the linear layer 16 by 4 by 4? See, this is what I'm not sure, but I suppose obviously it's based on the output from conv2D. 16 by 4 by 4 is interesting to me. Okay, so we're just gonna do this. Okay, and then 16 and 4. Obviously, this is going to make it see 32, 64, right? So this will be 64, and then 256. Does that make this 256 here? Did I math this out right? I'm gonna check really quick. Calculator. Simple math. All right, simple math. All right, 16 times 4 times for the 3D. If we did 3D, got it. Okay, which would make sense. All right, so what is our okay? What else do we have here? Pool ReLU. Oh, I see what's going on. I see. All right, so the forward pass, it's I don't know if we can do, because I'm reading the forward pass here, the way how it works, I don't know if we can do a sequential. Although I suppose maybe apply first convolutional, which is conv1. Where was the conv1? Oh, we did a conv. Oh, got it. Okay, so these are just 2. Okay, so this is the first conv. Sounds good. X, and then it does ReLU, and then it does pool. Okay, so we need to do like this. Wait, let me read this. No, conv1 ReLU needs to go here. Okay, and then pool on the outside. All right, so there we go. All right, so now we've done the sequence here. We got the sequence, and then what does the next look like here? So then it goes through the second and another ReLU and another pool. Okay, so we can do second ReLU and then pool again. What pool was it though? There's only one pool. Okay, so there we go. I think that's the same. I'm pretty sure that's the same. Let's double check it. Okay. Conv1, yes. ReLU, yep. Max pool, yes. And then we do conv2, yep. ReLU, and then pool. Okay, excellent. And then it looks like there is some sort of flatten here. Flatten all the dimensions except the batch. Okay, so this can we do a flatten here? I don't know if we can. Is it possible to do in.flat? Something like that. I don't know if we can. Does that work? Can we do that? Let's see, Python, import Pytorch. Did I spell it right? Just torch. Okay. And then torch.nn.flatten. Yes, it is. Okay, great. Excellent. This wrong, Steven. You need to run some feature engineering here. Like the input shape should be changed. Yes, you're 100% right. I got that. 100%. Neva, you're right. I know we have to do that. I'm very, very sure we have to do that. Because I need to change it so that way this is, I can get the right input shape for the first layer. Currently, it is only, it's a one-dimensional array with 6 input features. So we do need to change that. We do got to change that. You're totally right. You're absolutely right. We got to change that. We'll change it. To do, change input for CNN. All right. So we got to do that. All right. That's to our CNN. I really would like to make sure that we definitely get that going. I think we can make it work. I'm pretty sure we can make it work. Okay. So flatten, I think we got all this correct. So now the only thing we have to do is change the input. We're making an AI. Oh, all right, check this out. Here, let's undo this. Let's undo this really quick. Here, I'll show you. Check this out. This is what we're doing. Don't go anywhere. Stay right there. Here, I'll undo this. There we go. All right, so that should work. I'm pretty sure. We'll find out. All right, let's try to run this. All right, let's see if this works. Did we get it work? Okay. All right, perfect. So we're building a click predictor. Would love to watch this. All right, SAQ1000, we'll definitely watch it. So this click predictor, as you can see, all these green dots here on the screen, those are my clicks. I clicked there. And the yellow dot is where the AI is predicting the next click to occur. And it's learning over time. Obviously, performing is strange. It's not performing in the way I want to. So we're upgrading the model, the AI model, to be, instead of like an MLP, we're upgrading it to a CNN, a convolutional neural network, which will have context to positions. As it has multiple filters, as it passes through each of our inputs, will give us the ability to recognize a pattern, like a circle, or a square, or a rectangle. And it should see my pattern because I was doing patterns like this. I was like clicking on the screen in corners like this. So it should be able to predict very well when it sees a pattern like this. And right now it's kind of centering it, which means it's giving us an average, and that's not what we're looking for. We need a different pattern. So that's the plan for it. Seems like yellow is an average, so not what we're looking for. Yeah, exactly. You're right. Exactly. We need it to be actually predicting where the next click is going to be, right? Sivan, you're 100% right. So it is currently the average. We need it to be the actual predicted output. So in order to do that, we need to convert our model from a standard linear MLP into a convolutional neural network, which is what we have here. So there we go. Let's do that. Boom. All right. So now what we got to do is we got to convert the input to match what the CNN is looking for, which I do believe is a multi-dimensional. It'll be multi-dimensional. So I just need to convert it. Quantified quantum, we got to vanish. Got some reading to do. All right. Sounds good to me. Sounds good to me. All right. Let me see here. Make sure we got everything in the right spot. We do. We have everything in the correct spot. So let's convert. Okay. So we need to go to the forward pass now. Where's our forward pass here? And then our features will be encoded. However, we need to add an extra CNN step. So let's do this. Def CNN forward encoder. Did we where's our forward at? Oh, okay. So forward features encoder, then CNN encoder. Let's see if we get a different error if we move that out. Okay, so we do expected 3D unbatched or 4D batched input, but got input size of 6. Okay. So this is the shape that we need to convert it into. So let's copy and paste this. All right. If it's inefficient, you're making weirdness around gradients, which is very scary. Like try always avoid to NumPy. Got it. Is there a way that I can manipulate the torch array? Because right now it says it does not like it unless because the problem is I've already converted it to a torch array here. I converted it to a torch array. And what I need to do is, this is the normalization step. So I'm doing normalization here where it takes the screen resolution and the coordinate of the pixel or the click coordinate, and it converts it obviously from 100 by 100 down to 0.1 to 0.1. So we're normalizing it here. And we need to keep that. Obviously, it's got to be kept the same, that normalization. How do we do this? Okay, so where is the output look like here? I need to scroll up here. Okay, encoder matrix. It's the same thing. It didn't do anything. It just, it increased it? Tensor, no, it didn't even add. It didn't even modify it. It did nothing. Or did it? No. Okay, it did. Okay, I see. So it did a math operation to add it. But I want to, I get the math operation. I see what I'm doing. It's just that I want to convert 1D tensor to a 2D tensor. Yeah, so anytime just try NumPy and see if it breaks to do something else. Is Google kind of abandoning their TensorFlow? That's a good question. Are they? Are they going all in on Pytorch? I don't know. I don't know, because TensorFlow is great, especially with keras. Very easy to use. Very easy. I very much love it. Okay, let's see here. Let's ask for some help. Okay. How to convert Pytorch 1D tensor to a 2D tensor without breaking into non-tensor like array or NumPy. Is that possible? Can we do that? Is it possible? Reshape. Okay, so there's a reshape command. I should have known that. I should have known that. I should have known that the whole time. All right. So let's go two by two. Let's do a reshape. Okay. So we are a 4x4, a 1 by 4x4, right? So which would get a 16, and the kernel size is 5x5, which is too big. So we could do can we do 3? Does that work? Okay, let's try that. Calculated padding, input size, channel 1 by 1, kernel size. Okay. You can do a lot with it. We're trying to get our input size to the right shape. So the kernel size can't be greater than the actual input size. Perfect. Exactly. All right. Kernel size 0. All right. Stride 3. Stride 2 with square kernels and equal stride. So is the kernel the view on the window? That's what I want to know. He had credentials. He's saying what he meant. What he's saying we can take with like a really, like we know what's going on there. We know. Can I do a conv1D instead? Conv1D, a 1D convolutional over an input signal composed of several input planes. So can we do a conv1D? Maybe we can convert this to a conv1D, and then we don't need to double encode. We could try that. Data to fit in the right spot. However, we need it bigger. I think we're just gonna go bigger input. There we go. We'll do bigger input. So let's try that and see if that works. Okay. 4x4 invalid. That's fine. I can do that. Reshape. No worries. We'll do 8. Let's try 8. What coding language? This is Python. So see, now we've got a kernel size that's not the right size. So then how about this? We need a 5x5, so we'll do 25. 25. 5x5, reshape. 5x5. There. It will fit now. It'll fit now. We've got the CNN. So here, check it out real quick. So I'm the CTO of PubNub, and these subtitles are powered through my technology. They are the transcoder that encodes voice to text is captured through a standard neural network, and then the data on the output side, the tokens, are transmitted over my network on my technology, and you can see how fast it is. It's transmitted in real time, and so you get this overlay here for open captions, these subtitles. It's really neat. And it's open source. If you want it, it's open source. It's on our Discord channel if you're interested. The CNN works with pixels. It can work with any floating point numbers, right? And we've got a grayscale picture at this point. We have a grayscale picture. Or can it work with any signal tokenized numerically? Numerically, yes, it can work with any numerals. I know it can work with numbers. I know it can. I've done it before. I just realized you're doing something kind of weird, which is First encoding as a float, then passing that float into the CNN. That might work, but not what I meant. Oh, really? Do we not have to do that? Well, I mean, it doesn't. We reshape and normalize it, so it turns that XY coordinate, which is like 100 by 100, down to 0.1, 0.1, and then we convert it into a one-dimensional array, and it looks like this. So you can see what these. This is what the what that looks like here. So you can see XY. That's one XY. Here's another XY. Here's another XY, and then another XY. Right? So it goes like that, and then it just repeats. And so it's XY, XY, XY. Oh, we switched to CNNs. Yeah, hey, Kevin McAllister. Yeah, we're doing CNNs. We're struggling. I'm trying to get the input to work properly. I'm saying do CNN. Yes, so MNest is an MLP. Oh, it is. Got it. Okay, so then we're doing it weird then. So what if we didn't do any encoding? Okay. Okay, Neva, we'll try it. We'll try this. Some people saying AI at Google is funny. Let's check it out. All right, Neva, we'll try it.
Generative AI. Third, AI. Deploying AI. Finally, rigorously tested AI with AI.
Yeah. Large language models with AI.
Power of AI, generative AI, AI platform, AI.
Tailwind. AI first AI model.
The moon landing is AI generated.
Generative AI. Powered by generative AI.
With AI at the center. Leading edge AI research with Google's AI in the cloud. Personal AI.
Building AI. Sorry.
AI. I'm thinking they used the word AI. Is that what that is? They're encode point XY size X, size Y. Floor. Oh, this is the resolution. Okay, yep. Output equals. How does that work? Oh, let's copy paste this. Okay. Encode 1 point. So, Okay. Encode point. So this will be the screen size. So you got the screen size, XY, right? I guess this width and height of the screen is my guess. Then you've got the position, and then you're creating an integer value that's very big. What is size XY? Actually, because you don't need, right? You don't need that, right? How does that X comma Y equals 1? Oh, so it's a position. Oh, I see. Okay. So you're making a giant image here. So you've made a large image, and then you're updating the points on the image. That is neat. We're going to have a giant, right? So a giant full screen array, two-dimensional array of, there's 0 by default. So 0, 0, 0, right? So that's what Neva's given us. We've got 0, 0, a whole bunch of zeros all over the place. And here as well. However, this one is going to be a 1. Like say we click here, that'll be a 1. And so that's what the picture looks like. Let's see, close that. Click. 0. And we are going to be a convolutional network. That's what we're doing. That's what's happening. A click predictor sounds dirty. I know it kind of does, right? A little bit. Sorry for not being super clear about when the idea might have needed to give you the code before streaming. It's all good. I really liked learning. So I like failure. That's one of my favorite things. I like to run up against what doesn't work. It teaches you more than anything else in the world. I really like to do it. It's my favorite. So Neva, we're off. We're doing good. Whoa. Hey, we got a super chat there. Thank you. I paved my own road. You paved your own road. Thank you. That's so. Thank you for that. What are you doing? I'm sending $2 over there. That's great. Thank you. I appreciate it. Also, you're gridding the pixels out. Yeah, the GM, Neva has helped us out a lot. That's what we're doing. So we're building a fake image for the CNN to work. Yep, you got it. We're building a fake image. That's what it is. That's it. What is a click predictor for? What is the game? So we can use this for checking and defensive AI defense. So we're building an AI to predict where the next click is going to be. And we can use that to predict whether it's a person or if it's an AI. We can find out if the click is a real human click or if it's a fake click, right? We can do a lot of things, and you can do a whole bunch more with this. It's a whole bunch more. That's just one of the examples. That's one of them. Hi, after a long time. Kingmaker, good to see ya. I love food. That's cool when you, cool though. It can predict when you click. It can predict anytime. You look handsome. Whoa, Pablo, thank you. Let's get this to run once through here. So 16 by very big. Can we do, let's see, 4. Let's do more. Make it smaller. Yeah, okay. So that did make it smaller. So I suppose we could go 1650. I mean, that's massive. Wait, 16 by 16 and 8 by... Oh, okay. Yep. There we go. Now we did it. We did it. Oh, I thought we did it. The size of tensor A32 must match the size of a tensor B. Oh, output minus labels. Oh, got it. Okay. That should work. Why is it not giving me a 2? What is the input resolution? Very big. Let's see, it's very big. Very, very big. All right, so 900. 900 by 500. So, kind of big. It's kind of big. Let's see here. But the output size should be 2, and this is where we're at right now. And this should be 2. So why it no worky? Why it no worky? The size of tensor 32. Where is post feature encoding? Yeah, it'll be a very big number. What is the output? Output minus? Okay, let's print this. Print output. Okay. Show me the code again. I want to run through the size. Are you talking about... Here, I'll commit it to Git. I'll commit it to Git so you can see all of it right away. Git status, Git add main and clicks. Partway CNN. There we go. Push. Okay. Here it is. Max pooling is something weird. We'll try making the second pool just 2x2. The second one, okay. The issue, you're returning a batch from forward, but trying a single label. Oh, is that the case? Okay, there we go. All right. Here we go. Labels and output, yeah. So to me, this looks like a one-dimensional output on the matrix. On the output is one-dimensional matrix with 30 of a length 32, and our labels, which is the target, is also one-dimensional but a length of 2. And so I can't understand why it's giving me 32. No, it's a 16 by 2. Oh, really? So there is no more pure data to train AI on. Oh, right. As more than 50% of the web is now AI generated. So going forward in the future, it's just going to eat itself. Batch size is 16. Got it. Why? Well, batch size. We're really only doing a batch size of 1. How? Because when I Oh, wait. Do you know Google Summer of Code? I remember Google Summer of Code. Yeah. I've never been in Google Summer of Code, but it looks like, it sounds like a really great program. Okay, so you're saying that the batch size, so it reads as a batch you need to make here, right here. So this, is this not the right way? Like, did I mess this up? This seems right to me. Because this is like one batch, right? So here is one batch with one picture. So add a dimension, like a 1 or something. 1, like that. Oh, whoa. Oh, hey, things are happening. Oh, Neva, you got it. You figured it out. Neva, look. Oh, we did it. I was about ready to give up. That I was like, hey, we have to go. But look. It's working. It's we might have to change up a few things, but it is doing something. Hey, we got it back. All right, we did it. Neva, look at that. Hey, things are happening. Hey, what a great. All right, now it's gone forever. Oh, it's back. Okay. Hey, we did it. It's still centering. It's still grabbing in the center. Oh, we'll have to do some more things. This is really neat. It is learning. It's doing a lot better than it was before. Like, there we go. What? Push it and I want to read why it works? Me too. I don't know why it's working. I just want to try it out. Open source is now an AI code dump zone, isn't it? It is. You're right. You're absolutely right. Wow, so cool. That was the culprit. What was the culprit? We were using a 3D-dimensional matrix, and it wanted a 4-dimensional matrix. Who would have thought? It wanted 4-dimensional, so I did 4D. Here we go. Isn't that neat? Click. So this is me clicking. Wow, look at that. This is so neat. Okay. All right. We do have to do an encoding bounding. We have to do encoding bounding. So when we decode it, we'll have to figure this out. We'll play. Oh, see, circle's coming back. It's coming back. There it goes. It's on its way. Nice. This is great. This is neat. Hey, we did it. All right. Well, I guess we'll, but why it wanted 4D? I don't know. Neva was like, hey, why don't we try 4D? And we did. So here, check this out right here. This is where, I don't know if you can see it on the screen. I'll put it into the center 1 second. Down, medium, here we go. Right here. That's where it is right there. Thank you for the likes, you guys. We did it right before we were about to head out. All it took was an extra 1 comma in there. Just a little bit one. And we, of course, we also had to update the output coordinate here as well. We had to change that. So 0, 0, and then 1, 1 here. Yeah, we did it, you guys. We did it. All right, thank you for joining, everyone. We had a great stream. Let's run that again to see what that looks like, just so we can call it out. Limit streaming text to 1 line, 2 line, cut some of the part. Oh yeah, because it expects a feature dimension. Ah, there we go, feature dimension. All right. Probably because of color, right? The channels, right? Red, green, blue, alpha. There we go. And so we needed batch and the features for the channels and the number of samples. It's technically bugged right now. Then, as far as I know, it's working. My usual, right on time. All right, you're right on time, and we're headed out. Yeah. You got it. Nice. All right, we did it. It's looking pretty good. So now all we have to do is change how we're training the AI. Change some of the models. Change what it's seeing. Maybe add more pixels to the picture so it knows what the last like 10 pixels are rather than the past 3 pixels or the coordinates, right? So there's a lot of things. So that's what we'll do tomorrow. We'll see if we can improve it. We got it working. I would send a PR fixing the shape issues. All right, sounds great. Before I do that, let me commit this here. See here. Git status, git add clicks and main, git commit m. Send the PR. CNN working. Okay. Push. There it goes. All right, bye you guys. I am headed out, but more weighted. It looks like it's still an average. It does, yeah. It does look like it's still an average. I think we can fix it. See you guys. Yep, we're headed out now. This was an incredible live. Thank you, Sivan. Thank you, everyone, for staying. Thank you, Neva, for helping us out. Kyle, thank you for hanging out. And Drawing Brothers, great to have you here. And everyone else as well. It was good to have you here. and Torva, of course, as well. Good night. Cool. Thank you, everyone. We'll be back tomorrow. The plan for tomorrow is we will improve this model now that we have a CNN that's working and we actually see that it's giving us pretty clean output.